Well, we know that if you have an increasing function, if you're asked to find the upper estimate for an increasing function, you would find the area of each of the n different rectangles in the Riemann sum. But for the actual length of the rectangle, you would consider in an increasing function the right endpoint. And the opposite would be true if it were a decreasing function. If it were a decreasing function and you were asked to find the upper estimate of the area under the curve, you would choose to use the left endpoint because that would be the higher of the two sides of the rectangle. But what would you do if you had a situation where the curve f is increasing and decreasing on the interval over which you're going to take this estimated area under the curve? Well, here's an example where we're given a function that both increases and decreases on the interval in question, and we're asked to find the upper estimate. This example is f of x equals negative x squared plus 4, and we're considering an interval of x values from negative 2 to x equals 2. We see that if we factor this function, that it's actually going to have x-intercepts at positive 2 comma 0 and the ordered pair negative 2 comma 0. And we're asked to consider 4 rectangles under the curve on that x interval. Well, it's a good idea to find out, either do the graph so you can see it, or if you don't want to do the graph or it's a little bit more difficult, you can use a test to find the intervals of increase and decrease on the x interval from negative 2 to 2. And the way you do that is take the first derivative test, take the first derivative of the function, you get negative 2x, get your critical number, that's x equals 0, use it to partition a number line of x values, and discover the regions, the intervals on which the derivative is positive, in other words, where the original function is increasing, and the intervals where the derivative is negative, those are the regions of the x-axis for which the original function is decreasing. So you can see in this sine graph, we found an increasing situation for the original function from negative infinity to 0 x interval, and the function is decreasing on the interval from 0 to positive infinity. Or you could just do the picture like we've done here of the graph to see that also. So here I am sketching f of x equals negative x squared plus 4. And they had asked in a situation like this for us to find the upper estimate. So we want to overestimate the area under the curve. Well, we're going to break it up into these two intervals, one where the function is increasing and the other where the function is decreasing. You see the picture here where we drew the picture from negative 2 to 2. And you can see for a sub 1, we have the increasing function from x equals negative 2 to x equals negative 1. For a sub 2 rectangle, we have the increasing function from negative 1 to 0. But then from 0 to 1, the function starts decreasing and continues to decrease on the last rectangle from 1 to 2. So for the upper estimate, to calculate the upper estimate from negative 2 to 0, we're going to use the wi, the width of each rectangle being x final minus x initial over n. So it's going to be 4 over 4, which is 1. So let's just take the area of the two rectangles related to the area under the curve of the increasing portion of the function. Length times width plus length times width. Okay, for the length, we're going to use the right endpoint of the first rectangle because that's the higher endpoint. Evaluate the function at negative 1. The same for the second. Evaluate the function at x equals 0. And that's going to give us the overestimate of the function of the area of each of those rectangles. So f of negative 1 is determined by going back to the original function. F of x equals negative parenthesis, if you factored out the negative sign, x squared minus 4. So we evaluate the function, and for the length, and multiply each of those lengths times w, which we found to be equal to 1. So we get 3 times 1 plus 4 times 1 equals 7. Okay, so that's the overestimate, the upper estimate of the area under the curve from x equals -2 to x equals 0. Now, for the decreasing portion of the function, we consider the interval from 0 to 2. So we're looking at the area of a sub 3 plus the area of rectangle a sub 4, length times width plus length times width. Now, this time, in order to get the upper estimate, we're going to be using the left endpoint, not the right endpoint, because the function is decreasing. So we evaluate the function at 0 for the length of a sub 3 and at 1 for a sub 4. And then when we're finished, we add these two results together and we get the entire area estimated, overestimated, I should say, the upper estimation of the area under the curve for the function f, a, is going to be approximately 7 plus 7, which is equal to 14 units, square units.